8.2 product and a quotient of function. So we did addition and subtraction of function, right? Now we have two function product of that. I want to multiply these two. See, it is x plus 3. I'm multiplying by x power 2 plus 8x plus 15. So, okay, here we multiply that. We can expand that. See, x multiplied by x power 2 is x power 3. X multiplied by 8x is 8x power 2. 3 multiplied by x power 2. I can do that. So this is expansion. But what I prefer is you write it in a factor form, right? It's much more better. See, x power 2 plus 8x plus 15. You can write it as x plus 5, x plus 3, right? Basically, when you want to find the multiplication of that, let's say this is hx, f multiplied by g means x plus 3, x plus 3 is multiplied by what? X plus 5 multiplied by x plus 3. X plus 5 multiplied by x plus 3. So here is x plus 3 to the power of 2. Multiplied by x plus 5. So before we know how to graph that, we know the degree is 3. You know the power of that is 2. The power here is 1. The degree is 3. Leading coefficient is positive. So the ending behavior is going to be from here to here. I'm going to put the zeros first. So the 0 from this bracket is -3. You put this bracket equal to 0, you get -3 is there. And here is -5. 1, 2, 3, 4, 5. So basically you have to start from here and end here. So you start from here. For x plus 5, the power is 1. So the behavior is like a linear. You just pass through this point. Here, since this power is 2, it should be like quadratic. It should turn here. When you get to this 0 here, you have to touch the graph and turn. Okay. So the y-intercept is easy. Just put x0, then it's going to be 9 multiplied by 5. It's going to be 45. It's going to be your y-intercept. And you can graph that one. Do you have any question? So this is another one. Y is equal to f of x divided by gx. Now I want to divide these two functions. So the f of x plus x plus 3 and g of x is x power 2 plus 8x plus 15. Again, x power 2 plus 8x plus 15, you write in a factor form. You know, we have x power 3 from numerator and denominator, you cancel it. When you cancel something from numerator and denominator, you have a restriction. The restriction is x cannot be what? -3. So, but since it's canceled, this is a hole. On your graph, you have an empty circle, a hole. Here, another restriction, x cannot be what? X cannot be -5, but this one gonna be your vertical asymptote because this is a restriction in denominator. Again, you wanna draw this. So x equal to -5. 1, 2, 3, 5. Right? I'm just gonna put my big scale here to be 1 here is better. So if I put -3 for x, this is x, this is y. If I put my x to be -3 here, -3 plus 2 is going to be 1/2. But this point will be my restriction. This is going to be the whole, right? It would be, I put an empty circle here. See, this will be a hole. And from that hole, you can And you have a horizontal asymptote at y equal to 0. Y equal to 0 is going to be my horizontal asymptote. How do I know the horizontal asymptote? Y equal to coefficient of x in numerator divided by coefficient of x in denominator. Coefficient of the x in numerator, we don't have any x, so it's going to be 0. Coefficient of the x in denominator is 1. So this will be your horizontal asymptote. I did graph it. So from this, you go toward the asymptote without touching it. You go toward asymptote without touching it. You find another point here. Let's say you can choose, this is negative, so you can choose -6. If you put -6 here, you get -1 over -1, which is -1. So the -1 is here, so basically it's there. Again, from that point, you go toward the asymptote without touching your graph, very close that. Here you go toward asymptote, but not touching your graph. And that would be the graph of this function. Any question? Okay, so you do question number 1. Basically, f of x and gx is given to you the same way that I did, just multiply them and then graph it, divide it, and here is divide the other one, divide by the other one. Also, there's one more question here. You just multiply them, right? And here you just divide them and you just graph it and you're saying the domain and range for these two functions.